A second method for adding vectors is the triangle rule. All right, so step number 1 is draw 1 vector's tail from the origin to draw the second vector's tail from the first. I guess if I'm using abbreviations, I need to stick with it. From the first vector, tip 3, connect first vector's tail to second vector's tip. And this will equal the resultant vector. And then 4, use law of sine and cosine. Let's say that we are given vertical x and y, where we have force 1 that is acting at 30 degrees from the vertical, 250 pounds, and then force 2 is acting 45 degrees. Force 2 equals 375 pounds. 30 degrees, 45 degrees, and I wish to find the resultant force of F1 plus F2. All right, step number 1 is I need to take F2's tail and put it on F1's tip. So that's going to come down here. F2, and again I'm going to call it prime because it's a moved vector. Okay, and it is still acting 45 degrees from the horizontal. All right, and then step number 2 is connect the tail of F1 to the tip of F2. So that's going to be this right here. That is my resultant force. Okay, and I've drawn it really, really tiny here because I'm not drawing anything to scale. But that's going to be the orientation of my resultant force. Okay, by the way, you could also take F1's tail and put it at the tip of F2 and end up with the same answer. It doesn't matter. Okay, and we've got our right triangle here, and now this should look exactly the same as the situation with the parallelogram, so that we have our theta there. And let's see, if this is 90 degrees, that makes this little angle right here 60 degrees. So theta is going to equal to 180 degrees minus that 60 degrees from force 1, and then minus another 45 degrees from force 2. So theta is going to equal to 75 degrees. So using law of cosines, our resultant force is going to equal the square root of 250 squared plus 375 squared minus 2 times 250 times 375 times the cosine of 75 degrees. The magnitude of the resultant force is 393 pounds in 3 significant digits. The orientation of the resultant force, okay, because I drew this really small, okay, we've got this huge angle here, which is opposite of force 2, so I'm going to call it theta 2, all right, and it is theta 2 is going to be the remainder of this angle, which is 60 degrees, right? If it's 30 degrees from the vertical, it's going to be 60 degrees from the horizontal. So that is 60 degrees plus that orientation to the resultant force, alpha. Kind of wrote that funny. So alpha is equal to theta 2 minus 60 degrees. All right. So I need to find theta 2, and I'm going to do that with law of sines. So we will have force 2, which is 375 pounds over sine of theta 2, and that is going to equal to my resultant force, 393 pounds over sine of 75 degrees. Theta 2 is equal to 67.1 degrees. I'm going to plug theta 2 in up here. So alpha is equal to 67.1 degrees minus 60 degrees, and that is 7.11 degrees. And if you're wondering where all my significant digits are from, in my calculator I'm keeping more than 3 significant digits. That means our final answer is the resultant vector is equal to 393 pounds acting at 7.11 degrees negative from that horizontal axis. Vector subtraction is just like vector addition, but we add another step. So let's say, because there is no such thing as subtraction, so what we have to do is make one of the vectors negative and then add them together. Okay, yes, it's the same thing, but it's not the same thing. All right, so let's say that we're given x and y, and we have a vector here. I believe we've seen this one before. Of force 1 is equal to 3 kilonewtons acting at 30 degrees from the horizontal. And then we have force 2, which is 4.2 kilonewtons acting at 17 degrees from the vertical. And I wish to find, let's see, you are the given. I wish to find the resultant force, that is force 1 minus force 2. Okay, now with addition, it didn't matter which ones we did tip to tail for the triangle rule. With subtraction, it's not going to matter either which one's tip to tail. What does matter is which one is negative. Okay, that changes the answer if we flip force 1 instead of force 2. So we need to flip force 2 to get our answer here. Okay, so that is going to be down this way. Okay, so that would be negative force 2. Okay, so I flipped that, and I'm going to continue with triangle rule here. So I'm going to put the negative force 2's tail, negative F2 prime, which still has a magnitude of 4.2 kilonewtons. Okay, it's just now acting down, and it is still 17 degrees from the vertical axis. Those two things haven't changed, okay? I just flipped the tip and the tail for that negative scalar multiplication. And then I'm going to connect the tail of F1 to the tip of F2. And that will be my resultant force. Okay. First thing I need for my solution is the angle theta across from R. Theta. So let's put a horizontal line here. All right, so that makes this one 30 degrees, and that makes this one 90 minus 17, or 73 degrees. So my theta is going to equal to 180 degrees minus 30 degrees minus 73 degrees, which gives me 77 degrees for that angle. My resultant magnitude, using law of cosines, is going to be the square root of 3 squared plus 4.2 squared minus 2 times 3 times 4.2 cosine of 77 degrees. And that gives me a resultant magnitude of 4.58 kilonewtons. And then I need an orientation. Okay, so once again, I'm going to kind of do this, and I'm going to call U theta 2, and I'm going to call U alpha. So alpha is going to equal to theta 2 minus 30 degrees, because I want that orientation from the positive x-axis. And using law of sines, I can get theta 2. So we have 4.2 kilonewtons over sine of theta 2 is equal to my resultant force, 4.58 kilonewtons over the angle it's opposite, which is 77 degrees. Oh, sine of 77 degrees, I apologize. And we get theta 2 is equal to 63.3 degrees. Plugging that into there, we are left with alpha is equal to 33.3 degrees. So my final answer is my resultant vector is equal to 4.58 kilonewtons at a negative 33.3 degree angle.